The title of my talk is Special Considerations of Regeneration Pests. And when we started working on this, I kind of had an idea of where I wanted to go with this talk. And then I wasn't really happy with what I came up with. So I kind of merged the two ideas that I had together. What's the conditions that we have in the Western Gulf and how maybe they're changing, and what we deal with and what we know about certain insect pests. So I kind of molded those two ideas together like Carl Spackler and Caddyshack, and I think I've come up with something that'll be pretty effective. So when we look at the Western Gulf or the Gulf of Mexico and how we grow trees and deal with insect pests along there, there's basically a spectrum. And on the eastern side, we deal with wetter temperatures. We have soils that are a little more varied in their composition. They're made out of the weathered rocks and things out of the Appalachians. There's more of a dominant role of more frequent fires out east, and they suffer more and more severe major disturbances like hurricanes. When we come west, where we are here in Texas and kind of west of the Mississippi River, the soils get a little sandier. They're aeolian deposited. We get a little drier climatic conditions, and we have a lot of different issues associated with those kind of things. What I want to look at when we look at herbivory and insect pests and regeneration pests are a couple things: the temperatures, the water regimes that we deal with, and then some competition and predation issues. And we'll kind of hit these topics as we look at a few things. If we look at our temperatures in the Western Gulf and what we see as maybe a prediction by NOAA and the Union of Concerned Scientists and these different climatic looking groups, we're looking at warm temperatures, extreme warm temperatures, and very variable temperatures, but the trend seems to be more warmth. And what that has a lot of different implications for us here in the Western Gulf. We're looking at potential for sea level rises, where we get coastal salt encroachment, we get a decline in our estuaries, and this will lead to increased tree stress and then mortality. We look at increased summer temperatures, highs, and increased winter lows. These very minute fluctuations, though, there's only a couple degrees Fahrenheit or whatever, they have some pretty large implications for insect fecundity, where we get more generations perhaps, we get more eggs produced, and we start to see a rapid growth in insect populations. We see that also with our decrease in winter spells, winter cold spells. And then we have this idea that the frost line is maybe shifting northward, where that allows for an expansion of invasive species. We start to see some herbivore insect pests start expanding northward, maybe switching hosts from their traditional things. So we have to kind of take that into account when we look at temperatures. The other major factor we want to look at is some water issues. And no matter what happens rainfall-wise, whether we get more rain, whether our rainfall levels stay the same, we know that human consumption of our water resource will continue to rise. And that's a huge issue here in the state of Louisiana and the state of Texas. So it doesn't really matter how much rain we get. As the humans were sucking more of the water out of the ground, we have that impact on our trees that we're making our host trees more stressed and therefore more susceptible to insect herbivory. The predictions are that these kind of droughts that we have that last a couple years and then we get a little rainfall relief, those droughts will be magnified in extent and duration. And those are kind of issues that also affect, of course, tree health. And these shifting climatic patterns and moisture changes will affect our forest dynamics and their composition. We know, that our pines can tolerate our lower moisture levels than our oaks and hardwood components, and that allows for more herbivore range expansion. So we're looking at some different fluctuations. When we look at the interaction with the hosts, with our Western Gulf climatic factors, and with our insect pests, they're all interrelated, and how they exactly work is variable. We're going to talk about 3 pests here in a second, and some of the things that we know about these insect pests we may not really know about them anymore. As we look at how they respond to, especially to temperature fluctuations, what we will actually see on the ground may be completely different than what's been reported in the literature, and we'll talk about some of that and the management implications it has. So this interaction here is extremely important, and like we learned in forestry school, the one answer to every question is, it depends. It depends on what we're talking about, and how we get there is a mystery. So let's look at 3 pests. Our first speaker mentioned the 3 pests we were going to talk about: Texas leaf-cutting ants, we're going to look at titmoth, and then we're going to look at some regeneration weevils. So the Texas leaf-cutting ant is a social insect, of course. It forms large nests. They forage on foliage, clipping green foliage to take into the nest to grow fungus upon, which they feed. Quite an interesting insect. And they are a pest of young pine because in the wintertime, with the lack of available deciduous foliage to feed upon, they have to forage on something to feed the fungal gardens, so they will clip pine needles. Not a preferred source, but the only green source out there. So here they are clipping away on their pine needles, causing the damage that we see. And they will wreak some serious havoc on pine plantations. Typically, if our trees get to be about 15 years old or so, the leaves become less palatable, or the needles become less palatable, and it becomes too energy inefficient for the ants to crawl up to the trees and harvest the needles, so they switch to smaller other trees. They grow this little fungus. This is what they feed upon, and a lot of the management activities initially to eradicate leaf-cutting ants off-site was directed at fungus, trying different fungicides, trying to kill the fungus, kill the food source, and it really wasn't very effective. It is a problem because it's a long-term effect. Once the seedlings get put in the ground, the leafcutters get in on them, they wipe them out. They have a foraging radius of about 250 feet or so, and if you multiply that out, that's about a 4.5 acre impact on a tract. And once those seedlings are gone, they're gone. They're not just reduced in vigor or anything like that. They are killed, and we end up with these nice little holes in our plantations that will remain there until they get colonized by other pioneer species. Here's a 10-year-old plantation with a nice hole in the middle of it right there from leafcutters. One of the things that are very interesting about these insects is that their range is very limited. We're basically tied to Texas and Louisiana, and that's about as far as they go. They don't really go very far north into Arkansas because the soils get too rocky for them. The existence of the leaf-cutting ant is tied to the soil more than anything else. So the construction of the nest and the maintenance of the nest is paramount to their success. They look for these super sandy sites, 98% sand or so and about 2% clay, which means that as our temperatures warm up, as we start to see more conditions that would be favorable for overall insect herbivore growth and expansion, the range of the leafcutters is not expected to expand just because the soils aren't right for them. Here's a nice cutaway of the nest. It shows the central nest up on the top where the ants forage. They come in and out. They have these connecting tunnels to the underground complex where they have their fungal gardens and all this kind of good stuff. And what we see is we see chambers that go down and tubes and tunnels that go down into the water table, because in order to grow the fungus, they have to have and maintain a certain humidity level inside the nest. Well, as we get a decreased water table, right, we're sucking more water out of the ground, we're having less water come in by rain, that water table gets a little further away from the leafcutters, and it makes it harder for them to make nests in certain sites. So maybe with changing conditions here in the Western Gulf, we might see less impact from the leafcutter ants, which is a good thing. We know that with our warmer temperatures that we're going to see our deciduous plants sticking around a little bit longer throughout the growing season, which means as a preferred food source, the leafcutters should feed on those more than they would feed on our pines, which is good for us here in the pine growing business. And we know that because we're planting good quality, top-notch genetics at good spacing that our pines that we are growing should grow and out-accelerate any effects from the Texas leaf-cutting ant. So overall, will Texas leaf-cutting ants be a problem in the future? Perhaps, maybe a little lesser than it is today. What do we do about that? We have a couple management strategies that we can use. The first is a very simple silvicultural strategy, and that's to avoid bare soil during the mating flight season when the ants get established. They mate up in the air, they have infrared kind of sensors in their eyes, they look for bare patches of soil on the ground, and they land and start to produce colonies. So by maintaining some sort of vegetative cover on our tracks before we plant them during this critical May-June period, we can hopefully keep the leaf cutters off site. They'll go and they'll land on the side of a road or something like that. But exposing your site to bare soil during the mating flight is a very dangerous thing. Leaf cutters will come in. We want to herbicide as close to our planting as possible in that case to keep the leaf cutters away from the site. That bare soil is the attractant. When we find the colonies, typically once the leaf cutters land on the ground, fertile queen, she spits out some eggs and starts to lay eggs and produce young, buries the ground and starts a nest going. It's about 6 months or so before we see a nest that's large enough to kind of identify as a center leaf cutter nest colony and something that is treatable. So what we need to do is maintain vigilance on the tracks, look for these early nests, and treat them with insecticides as soon as we can. We have a couple baits that are used, a couple insecticides that we are registered for use on leaf cutters. We'll talk about those. But we are working as part of our Forest Pest Management Cooperative on new baits right now. Actually, the guys out in the field today testing some stuff. So what we know is previous efforts to kill leaf cutters with methyl bromide were very successful, but that's a dangerous gas and people don't like to keel over at the side of the nest, so we stopped using that. Some other baits were developed that were 100% effective on leafcutter ants, but those were discontinued for various reasons. There were some fluoramids, they had some environmental impacts, so those are no longer available. We have one bait that's currently registered right now for leafcutter ants, and that's Amdro Ant Block. It's a commercial, you can go to Lowe's and buy this stuff. It is not super effective on leafcutters. Our research shows that it's only about 30% effective. So putting it on the colony makes you feel good. It kills about 30% of the leaf cutters, and then you're back in a month treating them again. It's a compromised bait. It was also developed for use on fire ants, and the two insects have a completely different habitat, ecology, and everything, so it's not really good on either insect. So what we've done in our Forest Pest Management Cooperative is look at why this particular bait isn't very good on leafcutter ants. And it turns out that it has to do with the carrier of the bait. Leaf cutters are herbivores, and they're looking for more of a plant-based carrier binder, whereas the Amdro Ant Block has a lot of protein in it to attract fire ants. Not ideal for either one. So by tweaking the formula just a little bit and putting a little more foliage bait, and there we use citrus pulp, it is much more attractive to the leaf cutters. We've also discovered that the size of the pellet is more key than the actual composition of the bait. That the pellet size of Amdro Ant Block is too small for the leaf cutters. They like a larger pellet, a larger load to take down into the nest, and so they will forage on it more heavily if the pellet size is larger. So some work has been done by Dr. Paul Nestor with Texas AgriLife, and he has gotten together with some folks, and they are now repackaging, resizing the pellet of Amdro Ant Block, and that is going to be commercially available here in the near future, registered for use on leafcutter ants, and that's going to be effective because the ants will actually take the bait into the nest. So he's done some work looking at some Syngenta and Amdro ant baits, and basically this is a nice little chart that shows you measure the area of your central nest either in square feet or meters, and it will tell you exactly how much of each bait to put on there. These are the reformulated size, so this will be incorporated into the label of the bait. It's a good deal, but they really want you to limit, the federal limit on the label is 2 pounds of active ingredient per acre. So when we look at our leafcutter size, our leafcutter nest size, we kind of approach that rather rapidly with a typical leafcutter colony size. There is an alternative, and this is a product that was developed for use against pine titmoth. This is a PTM. It's a fipronil product. It's a great thing. I like to learn how these things actually kill the insects. It's kind of a sadistic little thing I have. But this actually blocks the passage of chlorine in through their cells, results in their paralysis, and the insects die. This is now registered, or has been for the last couple of years, registered for use on leaf cutters. It's a liquid solution. It costs about $300 a gallon, so it's fairly expensive. But you dilute it down and you walk around and you use a soil injector and you spray it into each of the entrance holes on the nest. This can be somewhat labor intensive. This is a typical size nest. There's over 300 different entrance holes. Each one of those entrance holes would need an ounce or so, a little squirt of the formula to kill the leaf cutters. It is effective, and we've seen 98 to 100% efficacy with one application of the PTM. It's nice stuff. And here's basically a chart. You are limited to 21 fluid ounces of the PTM per acre per year, which is more than enough to get a large size nest under control. And you'll have maybe one large size nest on an acre. So one nest treatment will solve your problem. The second pest we want to talk about is titmoth. And this has long been considered the major regeneration pest in the Western Gulf. What we're going to talk about today may reinforce that. It may change the way you think about it a little bit, because some of the research that we've done as part of our co-op shows maybe that what we've known historically about this insect and the impact that it has on our seedlings isn't necessarily in line with some of the research that's been historically done in the past. So here's our critter of concern, the Nantucket pine titmoth. A little small creature. Here he is on a pine needle. Their range is shown in this diagram. In the eastern Gulf, they actually have 4 species of titmoth that they deal with. We're very fortunate here west of the Mississippi to only deal with Frustrana, the Nantucket pine titmoth. So that's what we'll focus on today. The Nantucket pine titmoth is a moth, so he has 4 life stages, and what we're really concerned with is the larval stage and the pupal stage for management, but we do all of our monitoring of the adult stage. That's the one, of course, that flies around. And the research on titmoth historically has shown that they are very, very temperature sensitive, that the number of generations that we have of this moth is definitely tied to temperature regimes. And when we look at the studies of titmoth, starting up in Virginia, Maryland, and working across down the eastern seaboard and across the Gulf, we see basically 2 generations of this insect per year up in the Virginia area, and 5 or more generations per year here in Louisiana and Texas. So we have a little more conditions, a little warmer temperatures that are more conducive to this insect. We know that under cooler temperatures, the eggs for the Nantucket pine titmoth hatch in 30 days. Under warmer conditions, like we see here in East Texas, that's 5 to 10 days. And we expect from some of the research that we're doing in our cooperative that this rate might actually be shortened and that we might see egg development in as little as 3 or 4 days. That's some ongoing research we're working on now. So that allows for more generations of this insect and a longer duration of the problem that we have to deal with as land managers. The larvae develop, they bore into the shoots and they feed. They'll go down, they'll kill the terminal leader, and the secondary growth on that whirl of branches will start to compete for apical dominance, and we'll end up with this broomy, bushy seedling. The pupae then go down further into the stem of the shoot, where they pupate and they overwinter. Now, we've always learned and always been told that the majority of our damage from tip moth occurs in its first 5 years of the seedling. And that is true, but what we're now learning is that that may or may not really matter. So if you've been to a tract and seen tip moth damage, you see these red tips, you peel, you look in them, there's some white gooey stuff where the pitch and the larvae are down in there. And then the seedlings just look bushy and broomy, and they just look like they're not going to do very well. Some will die, of course, but some will continue to grow, and they just look not good. We know that when we have elevated winter temperatures, that the pupae actually survive better. They have higher mortality rates, up to 50% more, with about a 5-degree increase in temperature. So that's bad for us. But we also know that one of the ways that we manage Nantucket pine tip moth is to promote its natural enemies. So this warmer winter period will actually help the growth of its enemies, which is a good thing for us. We talked about how elevated temperatures increase fecundity and therefore more generations. But we hope, and what we're starting to see in some of our studies, is that this accelerated tree growth by planting better genetics, by planting out of better spacing, by using just a better tree to start with, one that's been containerized, for example, that we can maybe outcompete this growth or this damage from the tip moth and reduce the window of susceptibility to tip moth. So how do we manage it? Well, one, we want to promote the early crown closure of the stands. And that is a problem that we have as we plant trees on this increased spacing. So that's a kind of negative for us. We want to allow the weeds to grow over to promote habitat for its natural enemies. And one thing that I rarely see when I go and I visit tracts that are large, planted by industry, is that there's not a tip moth monitoring program going on out there. One of the important things that we need to do is monitor for the tip moth generations when they're actually emerging, because that's when we can go in and apply an insecticide spray. There is a trap with a sex pheromone that can be placed in the tract, usually at one of the corners, and it's just used to monitor the insect populations. You check it every couple of weeks and see how many moths you're catching, and that helps you time your spray applications, which is one of the big things that we deal with when we try to manage for Nantucket pine tip moth. Historically, we've been told, and the data seems to support, that if you spray just the first 2 generations of tip moth per year, that should control the rest of the losses from tip moth. That you will really hammer the first 2 generations and your problems will be majorly mitigated. The problem with that is that data on spray timing is based on a 40-year temperature mean and a lot of climate evaluations that's now having a shift away from what we've called a normal pattern. So we're looking at a new normal, which may require a recalibration of our spray timing models. Now, for those of y'all who don't have the spray timing tables handy or have them memorized for your local area, there's a research publication here by Chris Fettig and John Nowak and some others that are big in the tip moth world, and they actually provide charts based on weather station and by state on when you should spray for tip moth. So here's a chart that's for East Texas, or for Texas, and if I was planting pine trees in and around the Athens area, I would look for my first generation of tip moths to emerge somewhere between March 22nd and March 26th, where I would go for a spray event. And then I would look again in May, about the 21st to the 25th, for a second generation to go. And I would try to time my spray timing to whack those moths down while they're active as adults and coming out as larvae. So these spray timing tables are super important, and they're being revised to kind of reflect our changing conditions across the South. One of the things that we study in our forest pest management cooperative is the effect of adding PTM, adding imidacloprid tablets, and some other things, different treatments for tip moth, either at the time of planting, in the nursery, after planting, and so on, and what effect they actually have on overall growth. Right? Because that's the goal. We want tree growth at the end. We've always been told that the first 5 years are the most important years, and that's what really determines what's going to happen at the end of the tree's rotation. We've been following this particular study now. We're in our 6th year. And if we look at the results of this study, looking at different combinations of how we applied this kind of stuff, and its overall effect on diameter, volume, and growth over the years, the first 5 years, we saw a lot of variability. All of these treatments at the beginning had effect on growth as opposed to untreated trees. As time has progressed, that effect has diminished, and we see here in the 6th year of our study, the only statistical difference that we have in growth is a pine tip moth application, or a PTM application in the seedling, in the container, and then applied 2 years later in a solution next to the planted seedling. That is the only treatment that shows a difference in growth and volume after 6 years compared to an untreated tree. We're now in the 7th year of this study. We're measuring these trees again, and it looks like even that effect will be non-existent. What does that mean? That means 7 years after doing this treatment, your trees have the exact same volume and growth as they would have if you had done no treatment. That's an interesting thing. We're looking at form, right? So we know that those broomy trees have a really nasty form. They just don't look very good. So now we're looking at the form of those trees and rating that and looking at how that applies to our different treatments. But this data seems to suggest, this is one site in East Texas, but we've repeated it in Arkansas, we've repeated it in Louisiana, Mississippi, Alabama, that over time, the effects of your tip moth treatment really don't seem to matter that much. When we look at containerized and bare root seedlings across 6 sites, and this is all of our sites in Alabama and Arkansas, Oklahoma, we can see that our containerized seedlings actually show a better or more statistical growth than our unchecked trees, our untreated trees, or our bare root seedlings, except for bare root trees that were treated with a very low concentration of this. And we're not really sure where that data fits in. It seems a little anomalous. Interesting to note that if we look at raw numbers of tip moth attacks on containerized and bare root seedlings, the containerized seedlings actually suffer more attacks than the bare root seedlings do. Though it's not statistically different, the numbers are higher. It's not statistically different, but they are higher. But overall, it doesn't seem to matter to the trees, and we don't really understand why that is. Maybe those trees are a little healthier at the right time when the moths are emerging, and they go to it. We're not really sure, but it's an interesting deal. So this data seems to suggest that planting a good containerized seedling treated with PTM, either in a plug injection or a soil injection, gives you efficacy over tip moth than you would see, better treatment than you would see in bare root or unchecked or untreated trees. The last insect I want to talk about today are regeneration weevils. In East Texas, this is a problem for us, but it's not a huge problem. We get calls out. It's kind of a localized phenomenon. We'll see why that may or may not continue to be. But we're going to talk about Paley's weevil, Hylobius, and the pitch-eating weevil, Pachylobius, that are basically do the same thing, where the adults will feed on the cambium of small 1-year-old seedlings, but will occasionally feed on larger seedlings and small saplings. And sometimes in areas where we have localized heavy impacts for this insect, we're looking at 50 to 80% tree mortality. And I know I've looked at a couple sites up along the Red River and Bowie and Red River County in Texas where we've had several acres worth that were decimated by Paley's weevil. And when we look at the ecology of the Pales weevil, we kind of understand why and where those insects came from. We know that these weevils, the adults, those are the ones we're most worried about because those are the ones that do the damage, and those are the ones we can most easily treat. They feed at night or on cloudy days, and that on sunny days they will actually retreat down into the soil. On super sandy sites, they will actually go into the sand. They will feed on the roots and the cambium in the lower part that's buried below the soil, and your trees will just die and fall over, and it's really hard to determine what caused that problem. But if we look at the solar effects and we look at the sandiness of the soil, we can actually see, okay, yeah, that is a Pales weevil problem that we've been having. We're not really sure if this behavior that they have of feeding at night is the result of a light stimulus or a relative humidity stimulus. Do they hate the light enough, or are they encouraged by the cloudiness and the increased relative humidity? That's some of the research that's ongoing, and that's really all of the research that seems to be ongoing right now on Pales weevil. Seems the science has been pretty much settled on this guy and these regeneration weevils, and we're not really doing a lot of work with these things. So we know that if under our possible changing conditions where we see lower relative humidities, we see higher temperatures, we could see less regeneration weevil damage, and that's a good thing. We know that most of our damage from these critters occurs in March to April in the springtime because the adults are attracted to the cut stumps of pine trees or trees that have been killed by fire. They produce a specific odor. It's a pheromone that's attractive to the adult females, and they will come in and start establishing their eggs. The eggs are deposited in the root bark, and these insects are rather long-lived. They will overwinter twice in Canada, which indicates that they have a long life cycle that we need to deal with. We know that in the South, they have 1 or 2 generations if the late summer, early fall emerging adults get their eggs into cut stumps before the wintertime. That we can actually see 2 generations of that weevil, that those weevils deposited before wintertime will emerge before wintertime and start to feed and lay their own eggs. And so we can see 2 generations of that here. The pupal stage length, which is kind of the determining factor here, is very temperature dependent. It's only 2 to 4 weeks in the Western Gulf. It may be 5 to 6 weeks up in on the Eastern Gulf and up in the Piedmont. So when we look at elevated temperatures that are forecast, we look at shortened life cycles resulting in more generations of the insect per year. That's a problem for us. How do we manage it? Well, there are very few biological control agents that are out there for weevils. We know that there's a couple strains of muscadine fungus that will go and attack all stages of the weevil. And this is something that we would like to promote. We know that there's some protozoans and some nematodes that do the same thing that on the adults and larvae, and those are things that we need to promote through our silvicultural practices. And that's leaving some of the slash, or removing the slash, but leaving some other plants around, leaving some cover on the ground for these enemies to habitat. The problem we see is when we see these changing weather conditions, that they are not conducive for fungal growth, and they're not conducive for protozoan and nematode growth. So elevated temperatures, drier conditions do not promote our fungal pathogen on Pales weevils. So how are we going to manage it? Here's a couple guidelines. If you don't cut pine from an area that you're going to plant, if you're converting a pasture or something, you don't have to do anything because there won't be any weevils. They're attracted to those cut stumps. If you cut a pine stand before the 1st of June and you're going to plant it during the following winter, you won't have a weevil problem because the cut stump odors will dissipate, they'll go away, you won't get new weevil encroachment. If you cut a small amount, about 3 cords of pine, only pine, per acre from an area, after the 1st of June, you can expect about 5% loss if you plant the following winter. If you cut a moderate amount of pine, about 5 to 10 cords per acre, or push it down during site prep after the 1st of June, and you plant the following winter, you can expect paleys and regeneration weevil losses to be up to 25%. And if you put a lot of pulpwood on the ground, if you take a lot of pine out, and you do it after the 1st of June, and you plant the following winter, you need to definitely use treated seedlings or wait till the next season to plant to let those odors go away. Okay. So basically, weevil control is pretty much unnecessary in the winter and spring harvest because all the weevils have left before the next winter planting season. So here's a graph that shows your harvest month and your weevil potential. Control will be necessary during fall and summer cuts because you'll have newly arriving weevils colonizing, starting to overwinter, and feeding, and doing that process until June is. And that is something we want to avoid. So, as part of our site prep regime, we want to remove as many old dead stumps as we can because these are our weevil breeding sites. We want to, if possible, if the previous option is not possible, is to go ahead and drench those stumps in the surrounding soil with a registered insecticide. You can use Arctic, you can use Pounce. Between early April and mid-May, you only need to cut the cut stumps. And if possible, leave a whorl of live foliage, live branches on that stump if it starts to resprout, and leave it there because the weevils do not like that and they will not populate your tract. The best option, though, and the simplest option, is simply to delay your harvest if you can for about 6 to 9 months. You want those cut stumps to dry out and not produce the odors that are attractive to the adult weevils. And if you have to plant the tract within 6 months, consider the seedlings that are treated with Arctic or Pounce. And you can do that. Those can be applied in the nursery, in a container, or post-planting. That's what you want to do. Does anybody have any questions?
My question is there any difference in what the weevil reacts to if you're talking about a mixed parent hardwood stand versus a pure pine stand?
Yeah, for sure. So when you do your harvest, they're attracted to the odors from the cut stump. So anything that's in the hardwood that's going to mask that odor, help dissipate that odor, will be a preventative for weevil encroachment.
So the results are not going to be
as dramatic. Yeah, you'll probably get less weevils coming in.
Questions?
Sure.
Concerning the weevils, how does a site prep fire impact it if you want to plant?
Right. So the scorching, if it's not, killing everything out, and, nuking it, those odors remaining will be attracted to the weevils. So if you're going to burn it, what we want to do is try to wait 6 or so months afterwards to get the new planting done.
Concerning the ants, is there a connection to hickory trees? I had someone point that out to me that there's always a hickory tree around their nesting site, and I'm confirming 4 out of 5 that I've seen actually had hickory trees around it. I don't know if it's just a site or if it's the tree.
I would think that's a site deal. On a lot of the research that I did with them, yeah, there were a lot of hickory trees there because that was what was growing on their sites. But if you look at the other range of the ants, if you go the Guadalupe River out west to Uvalde, you don't see the hickories around there. And so the nests are just, I would say that's more anecdotal than anything.
Last thing, and this is funny, but I've had one landowner tell me this, have not confirmed it, no, not science-based, you're going to laugh at me, but he treated, with ant block, he treated ants 3 times, and he said it felt like he just moved them around.
Yeah, absolutely.
The last time, he never had to treat them again, he actually mixed grits with his ant block.
Oh.
He didn't have to treat them no more.
Right. So I've heard grits, orthene, all this kind of grape medicine orthene. I would say the grits maybe because it's a more plant-based carrier. And the ingredient in ant block works. It's just getting the ants to take it down. And so if you can mix it with the grits, I could see where that might work. But now the new formulation takes care of that for you. You don't have to waste good grits on that.
Gotcha. Thank you.
good southern ants eating grits.
Yeah. One of the other big problems we actually have with the leaf cutters is the range is so limited that none of the chemical companies are interested in producing new baits for them. I know all we have to do is reformulate this a little bit, but it's going to cost us $500,000 to just repackage it. We'll never make that money back selling for leaf cutter ant control. We're just not interested in doing it. And so that's been a major hurdle for control of these critters.
For the muscadine fungi, what silviculture practices exactly would you have to go to cultivate those further?
Yeah, I'm not sure. I think that's more of a pro-fungus agenda where you would need, moisture conditions, some shade, anything, I guess, where you're growing muscadine would promote that. So my point was we're getting warmer, we're getting drier, not great for fungus. We're seeing less infection of the weevils.